All right, let's dive straight in. If you're building agentic workflows right now, there's a massive, completely hidden security trap that you really need to know about. We're going to skip all the generic AI hype today and get right down into the technical trenches. Because, look, as developers, we are rapidly moving away from just using foundation models for, simple text generation. We're building autonomous agents that actually take actions in our systems. But there's a trap that a lot of incredibly smart engineers are falling right into when it comes to securing these agents. So in this explainer, we're going to break down exactly what that trap is, why it's so dangerous, and how we can rethink our architecture to build workflows that are actually truly secure.
To really understand the problem, let's start with a scenario that, you've probably seen, or honestly, maybe even built yourself. You're integrating an AI agent into your company's CRM. You want the agent to be super helpful, right? You want it to read records, summarize interactions, all that good stuff. But you absolutely do not want it dropping any critical data. So what do? You add a strict all-caps instruction right into your system prompt. Never delete customer data. You hit deploy, cross your fingers, and it feels secure. You've given the model its constitution, its hard boundaries.
But here's the multi-million-dollar question we have to ask ourselves as system architects. What happens if the model just ignores that instruction? What if it totally misunderstands the user's intent? Or worse, what if a malicious user feeds the agent conflicting context, like a hidden command tucked away inside an email through an indirect prompt injection? Think about it. If the delete operation is still technically available to the agent via that CRM tool it's holding, then your system prompt, it isn't a security boundary at all. It's just a behavioral request. It's essentially guidance. You're basically leaving the keys in the ignition of a sports car and leaving a sticky note on the dashboard that says, please, whatever you do, don't drive away.
And look, this isn't just some theoretical whiteboard exercise. When you hand a foundation model direct, unfiltered power over persistent state, you are empowering it to make completely destructive mistakes. There's an actual real-world case where an AI agent was tasked with optimizing a database's performance. And how did our helpful little agent achieve this optimization? By dropping half the rows from a production table, literally erase critical records in the process. And the crazy thing is, there was absolutely no malice involved. The model just misinterpreted the intent, and a totally harmless query mutated into a destructive command. This is exactly the danger of relying on prompt instructions to protect your stateful systems.
So this brings us to the absolute core thesis here. Prompt instructions cannot replace tool permissions. We have to clearly understand the difference between these two paradigms. On one hand, a prompt is just a semantic instruction. Do not delete customer records. The model actually has to process that, understand it, and then actively choose to obey it. But a permission? That's a hard architectural boundary. In this paradigm, delete customer is simply technically unavailable to the agent. The second approach is infinitely stronger because it removes the agent's agency over that specific, destructive action entirely.
Which brings us back to a classic engineering concept you already know, but one we desperately need to apply to AI, the principle of least privilege. We've got to start treating these large language models exactly like we would treat any other user or third-party integration in our stack. An agent should receive only the specific tools, the exact actions, and the precise data required to execute its exact workflow, and literally nothing more. If an agent's only job is to summarize customer tickets, it doesn't need and absolutely should not have the ability to modify those tickets.
To do this right, we're going to have to completely change our vocabulary. We really need to stop thinking in these massive, monolithic terms. Don't just sit in a meeting and say, okay, we're giving the agent CRM access or database access. That is just way, way too broad. Instead, we have to break permissions down into actual atomic operations. Just ask, does it need to read? Does it actually need to write? Should it have the ability to send an email, delete a record, approve a refund, charge a credit card, export a dataset, or heaven forbid, execute an admin function? Because each and every one of these operations carries distinctly different consequences and a wildly different blast radius if things go wrong.
Let's look at how this practically impacts your tool design. Contrast a generic, super powerful endpoint, like an admin tool that just takes an action in some arbitrary JSON payload, with narrowly scoped, state-safe procedures, like get order or update order status. That arbitrary endpoint on the left, that is highly dangerous because the attack surface is effectively infinite. You are blindly trusting the LLM to format the payload safely every single time. But by constraining the tool capabilities at the registration layer and defining single, well-tested procedures, you sharply reduce the scope of potential errors. Notice how I said draft refund or request refund approval, not execute refund? That distinction is absolutely huge. But hey, Limiting the tools isn't quite enough. We also have to interrogate the data scope. Even if your agent only has read permission, you've got to ask these rapid-fire questions during your code reviews. Which specific customers can it read? Is it properly restricted to just one tenant in your multi-tenant system? Which exact fields can it access? Like, does it really need to see personally identifiable information? Which documents? What time window are we looking at? And are we strictly keeping our dev, staging, and production environments isolated? Restricting the data scope can drastically reduce your blast radius, completely independently of how tightly scoped your tools actually are.
And this perfectly transitions us into the whole concept of safeguards. You need environment isolation. You need robust role-based access control, or RBAC. Think about it. If you build an agent and instruct it to summarize text, the underlying system architecture should literally block it from even attempting to make an external network request or execute random code. You've got to isolate the agent's operations using sandboxes or containers. That way, if the agent does go off the rails, whether that's through hallucination or some clever malicious exploitation, the damage is totally contained within a heavily restricted perimeter.
Let's visualize this. Think about what a bad architecture pipeline looks like. It's pretty straightforward and terrifying. The LLM processes the user prompt. Then, it directly accesses an overly permissive monolithic tool, like an admin CRM tool. And finally, it just executes an arbitrary, potentially destructive action directly against your stateful data. Boom! There's no friction, there's absolutely no oversight, and there is zero safety net if the model misinterprets the goal.
Now, a better architecture fundamentally shifts that very first step. In this model, the LLM doesn't execute an action, it proposes an action. That is a massive shift. From there, the deterministic system takes over. We run schema validation to ensure the data is formatted correctly. We run policy checks to make sure the action doesn't violate any business rules, followed by a hard permission check. Then comes a risk and consequence check. And for those high consequence actions, we require human approval, we route the request to a highly narrow tool, and finally we generate a state record. The system intercepts the action long before it ever touches your state.
Okay, I want to talk about a very real, very sneaky developer trap: permission creep. It almost always happens exactly like this. You start a new project. Hour 1, the agent is read-only. It's totally safe. But then, you realize the Friday afternoon demo to the PMs would look so much cooler if the agent could just update a status, so you casually give it write access. Week 1 rolls around, you want it to notify users, so you hook up an email capability. By month 1, someone gets sick of dealing with authentication hurdles in dev, and suddenly the agent ends up with a full admin credential. You've slowly, silently accumulated excessive capabilities just to make development easier. And eventually, one single model mistake is going to have a massive, system-wide blast radius. To fight this permission creep, you really need to implement what we call a practical permission review. Before you register any new tool for an agent, literally run through this checklist. What exact action and data are strictly required? Nothing more. What is the absolute maximum consequence if the model uses this tool maliciously or incorrectly? Is the action reversible, like, drafting an email? Or is it totally irreversible, like dropping a database table? Does it require human approval? Who actually owns it? What gets logged? And crucially, what is explicitly made unavailable to this tool? You have to maintain absolute predictability at the registration layer.
Which leads us to my absolute favorite thought experiment for evaluating agent architecture. I call it the prompt removal test. It is the ultimate architectural crucible. Go ask your engineering team this tomorrow. If the system prompt vanished entirely, like if all of your carefully crafted instructions to be helpful and secure were completely wiped out by an injection attack, what would still prevent that agent from deleting data, sending the wrong message, issuing a massive refund, crossing tenant boundaries, exporting sensitive info, or calling an admin tool?
If the answer to that question is nothing, if the prompt is quite literally the only thing standing between your agent and a totally destructive action, then I've got bad news. Your permission architecture is fundamentally incomplete. Let me reiterate this because it's that important. Prompts only influence behavior. Hard permissions constrain actual capability. You just cannot rely on semantics for security.
And that brings us to our final takeaway. If there is one single phrase I want you to walk away from this explainer with, and honestly plaster on your team's whiteboard, it is this: the model proposes, the system decides. Use the incredible intelligence of the LLM to navigate ambiguity and suggest the right tools, but use the deterministic, programmable logic of your application to actually enforce the boundaries. Use the absolute smallest authority surface possible that still creates useful leverage for you. By separating the agent's intent from the system's execution, you ensure your AI agents remain powerful, safe collaborators. So I'll leave you with this one thought to mull over.
If your system prompt just vanished overnight, how much damage could your AI agent actually do?